Poisson's distribution. Now, in Poisson's distribution, we describe the probability of a given number of events occurring in a fixed interval. But the important part I really want you to take note in this definition is it is when events happen rarely. That's very important. When events happen rarely. Now, what are the key characteristics of a Poisson's distribution? They use for rare events. I've told you already. Now get the basic concept of theoretical distributions. For normal distribution, you know that it's for continuous data sets, right? For binomial, it's when you have two possible outcomes. And for Poisson's distribution, it's when events happen rarely. Take note of those. And another characteristics of the Poisson distribution is when events occur independently, when events occur randomly, and it focuses on frequency. Those are the key characteristics of a Poisson's distribution. Now, example, especially in the healthcare, is the number of emergency cases arriving per hour, infection in a ward per week, medication error per month. Now, these events are usually rare and unpredictable. This is why we use Poisson's distribution. They are rare and unpredictable. This is why Poisson distribution is appropriate. Now, we use a simple scenario. In a hospital ward, the average number of medication error is 2 per week. So we have 2 medication errors per week on the average. Now the question is, what is the probability that exactly 4 medication occurs next week? We have 2 per week, right? What is the probability that 4 medication occurs? All right. So we use this another funky looking formula, and we're going to try and break each of them down. We have e raised to the power of minus lambda k, then all over k factorial. We break each of them down. What is e? E is approximately 2.718. What is lambda? Lambda is the average, which is most times given in the question, which in this case is 2 errors per week. What is k? Is the number of events we want. In this case, 4. So what you have in the question is the lambda. What you have in in what you are expecting is the k, and then e is a constant. So we're going to use this in a classical example. So now, replacing all the values, right? E, which I told you it's what, 2.718 raised to the power of minus 2. You can use your calculator to do this. You get 0.1353. That's this. Now, 2 raised to the power of 4 is 2 times 2 times 2 times 2, which if you do the math, you get 16. Then 4 factorial. 4 factorial is 4 times 3 times 2 times 1. You're just counting the numbers backward. 4 times 3 times 2 times 1. And that gives you 24. Now, putting all of this together, you will see that firstly we multiply the top part, which was e times 2 raised to the power of 4. That's 0.31353 times 16. So it gives us, this times this gives us 2.164, right? Divided by the 24, right? And this gives us 0.0902. So that means there is only a 9% chance that 4 medication errors will occur in a week. So that is how we use the formula in Poisson's distribution. We just replace the values with this. And the key concept in Poisson's distribution that it occurs when events happen rarely. when it happens rarely. And that's it about Poisson's distribution.